Welcome to qnawire.
In this problem on the topic of sources of magnetic fields, we are told that two long parallel wires, which are separated by a given distance, have currents I1 and I2 as shown. We want to calculate the magnitude of the force exerted by each wire on a 1.2 meter length of the other. We want to know if that force is repulsive or attractive, and then we want to know that what would happen if we double the current in terms of the force that is now exerted between the two wires. So let's look at part A, and keep in mind that two parallel conductors carrying current in the same direction will attract each other, while two parallel conductors carrying currents in opposite directions repel each other. So the force between two current-carrying conductors that are parallel is mu naught times I1 times I2 times the length of the wire L over 2 pi r. So this is essentially mu naught, or this is essentially F is equal to B L I. So now this can be written as mu naught, and we substitute our values in here. The first current is 5 amperes, and the second is 2 amperes. Mu naught is a constant, 4 pi times 10 to the minus 7 in SI units, and the length of wire in question is 1.2 meters long. This is all divided by 2 pi times the radius of the wire, 0.4 meters, or actually the separation between the wires, 0.4 meters. So if we solve for this force, we get the magnitude of this force between the two wires is 6 times 10 to the minus 6 newtons. And remember, the currents are in opposite directions, so this force is repulsive. Now that's our answer for part A. Now for part B, we want to know what will happen to the force if both currents are doubled. Now we can see that the force is linearly dependent on each of the currents. So if we double the currents, the force increases by a factor of 4. And so simply we can see the force is 4 times the force in part A, which is 2.4 times 10 to the minus 5 newtons.